Today we're going to implement authentication on our casino. To do this, we're going to use Keycloak. So in order to do this, we are going to start by going into our Docker Compose and copying over a Keycloak configuration I have from another project. And I'm going to explain this to you. So this is just a Keycloak image and we want the latest image. We're going to name our container Keycloak because that's what it is. We never restart it unless we say, okay, stop running casino to Docker. So this means that it will restart if it crashes, for example. In the environment variables, these are some basic variables for Keycloak to know how to configure itself. So the first time it will create an admin account with user admin and password admin. This is, I believe it's the default values, but I'm still setting them. As you might imagine, this says that the database we use is of type Postgres. This is the connection URL. This might be unfamiliar to you, but this basically is a Docker Compose thing or Docker thing, I'm not sure. But it will replace the IP from inside our Docker network to use the database IP here. And more specifically, we want to connect to the Keycloak database because in this database we'll have multiple databases. Username and password. It runs on port 8080 by default, and we're gonna keep that way because it doesn't bother us. We don't want this to run before the database has been initialized, and the command once the container is up is start dev. So this is what it will run once it starts up. About the volumes here, so this is where it will store the Keycloak data. You can notice by the name I named the file. And more importantly, here we're going to configure an init script that will run at the start of the Keycloak instance. But actually for now, we're going to remove this because we don't need init script right now because we're not going to create any default users and stuff like that. So I'm going to remove this, but we might implement this later on. And also here I'm going to create another for Keycloak data, just like this. Now, if I open a terminal and I run, let's just use node 20 and docker compose up. So I don't have Docker open on my PC, so I'm just gonna open it. Okay, there we go, and try this again. Okay, so this name is already in use by another one of my projects, so I'm just gonna rename this. But what you could also do is run a command to delete your old one if you want. But I'm just gonna rename it. I'm just gonna look up the command for you if you want to delete, if this happens to you. So if you just run docker rm postgresdb, so I made a typo, postgresdb, there you go, removed it, and now if I docker compose up, so I'm not actually going to rename it, I think. I have the same problem with Keycloak. I'm just going to rename these. I'm going to say casino postgresdb, and this means I'm going to have to replace it over here. So we're going to say casino. The Redis, oh, okay, well, we're going to do the same thing, same naming convention, and here casino Keycloak. Okay, there we go. Let's try again. Docker compose up. There we go. Okay, so now if we go onto localhost 8080, okay, let's see why. Okay, so I figured out why here in the logs you can read here. Where is it? Here, fatal password authentication failed because this is I changed this. So here the username is my user and the password is password, not your password. So I forgot to change this. So if we restart it, Docker compose up. Well, then still it doesn't work because it says the database Keycloak does not exist. So we're gonna have to create it. And in order to create this, I'm gonna come into my backend here. I'm not sure if I should put this in my backend or not. Now let's put it in the backend. I'm gonna put this in scripts. Let's put it here for now. I'm gonna put initdb, and we're gonna create an initialization script for the database so that it creates our databases by default. Up. So this little script that I got here takes in, well, it doesn't take it in argument. We hard code an array of database names and it checks whether those database exists, and if it doesn't, then it will create them. So now we need to tell Docker to run this script at the start. So in order to do that, we're going to go to Docker Compose here, and in our database, we are going to add this up. There we go. So now I will actually end up moving this over here because I don't think it's gonna work otherwise. Oh, I messed up the movement here. So I want to create the scripts folder at the root, remove the scripts folder here, and the initdb I want it inside the scripts over here. So we've got the scripts here at the root. There we go, at the same level of as the Docker Compose file. Also, before I forget, I'm gonna add the execution permissions plus x scripts initdb up. That way we won't have problems with that. Okay, so this should make sure that the database is created by default. Let's try once more. Docker compose up. Okay, it seems to be working fine. Now if we go again here on localhost, up, there we go. And now we can log in with our admin username and password that we created earlier. There we go. So we have Keycloak figured out. Now earlier I said that we're not going to configure Keycloak, but I think we will because we're going to want to replicate this environment. So we want to be able to create a client for Keycloak programmatically, well, by configuration I mean, and thus we're going to need a configuration script. So the way I do this is I'm going to create here an init Keycloak, and then here an init keycloak.sh. I'm gonna give it execution permissions as well, just like earlier. Now the way, so we're gonna fill this in a few seconds, but before I want to come configure the Docker Compose file. The way I do this is a bit dirty because I think there should be a better way, but I don't know the better way. So the way I configure it is I launch another pod, just a one-time pod that starts, uh, runs the configuration, and then stops. So I'm gonna copy this over. There we go. And so the volume that I added here extra earlier, we don't even need it because it's the configuration that will, it's this one-time pod that needs this volume, this one. And here this is init and init and init. So this pod will start and it will wait until the Keycloak is started up at this location. It will try to connect itself with the user admin and the password admin. So remember that if you change these values here, you need to replace them. And when it is ready, so when it does get a response from this, then it will run our script, our initialization script. And this one, it does not restart, not like these ones. So now let's go in our configuration here and let's start configuring. So this first part allows us to configure our KCADM, which is a script that allows us to communicate with Keycloak. So again, you specify the username and the password. So now here I define a variable for what I'm going to call our realm and our client ID. This creates the realm. And then this creates our client that we will use. And we hard code the secret here. This is just for now. We want it to work, but later later in a long time, when we're gonna deploy this to Kubernetes, we're gonna have to come change this so that it handles environments and doesn't hard code the secret inside the script. And same thing for the redirect URL because we'll want it to change according to our environment. But for now, this will do. Then after creating the client, we get its internal ID. So this is the ID inside the Keycloak, and we will update the client and activate some options. The standard flow enabled option allows us to enable OAuth 2 authorization. So this is needed for regular browser logins. So when a client uses your application, not a client, but a uses your application and your front end, which will and the user will log in using Keycloak. This one enables resource owner password credentials. So this allows your application to log in using a username and password. So this is for when you do want your server to have the password at some point. The reason we enable this is so that during our tests, our integration tests, we can create a bunch of users and log them in programmatically without a browser. But in production, you don't want to have this. And then the service accounts enabled is so that our client, so here, this client will be a service account, and it allows the client to make machine-to-machine requests, so directly communicate with Keycloak and access credentials of the users in order to provide them to our users. If this is useful for refresh tokens, for example. So as I said, we want in our integration tests to be able to create users and log them in. So this is what all of this does. It's a bit complex to read, but if you want to go through it, be my guest. All of this is basically set up in order to run this command, and this command allows your client ID to manage users in your Keycloak. Managing users means creating them, deleting them, and I think, yeah, that's it. Maybe editing them as well, but we're not going to do that. Now, next, we're going to create some roles. So the user role and the admin role. So here we go. We're going to create the user role, the admin role, and we're going to create a function that creates a user with a role. We set a hard-coded password because these are just going to be test users. These are just users during our integration test, so we don't really care about the password. So just random password, doesn't matter. And then we're going to come and call this function for our test users and our admin user during our integration tests. And now one last thing, here is a mapper. So what this does is, so Keycloak provides you with JWTs, and those JWTs have a bunch of fields on them, such as roles, but the user's roles are a bit nested. So what this does is it puts the roles of the user as a first field inside the JWT. So this is useful because then on the front end you can just access your JWT payload dot roles instead of going dot XYZ dot W. I don't remember the path. But basically this unnests the roles attribute in the JWT payload. Okay, so there we go. So now we have Keycloak set up. So now I think we're ready to launch Docker, compose up again. So here we can see that the script is running. It waited until it could connect to the Keycloak, and then it started by creating the realm, the client, and then creates the users and everything. Okay, so now that we have this set up, let's continue and make our auth module. So there we go. I copied over an auth module that I have, and we're gonna read over it and look at how I implemented this. So to start, we're gonna have to install some requirements such as Nest.js passport here, pnpm add app. So I am not in the right app, so I'm gonna go to the backend, oops, and add it. So while this is loading, we're gonna create an auth controller, an auth service as well, auth.service.ts. We're also gonna want to create an auth token service, token.service.ts. What else? We're gonna want an auth guard. So gql auth.guard.ts. And there's more, but let's start with this. This must be bugged because this is taking forever, so I'm gonna kill it and try again. So I don't know what's happening here. It doesn't want to continue. I'm just gonna let it run and continue implementing this. So we're gonna fix all of these errors. But for now, we're gonna create a controller, an empty controller just for now. So I'm gonna do this here. There we go. The controller gets imported from Nest.js common and the auth service. Well, we haven't implemented it, so let's go do that. So I got this from my other project, and I'm gonna explain this to you. So the OpenID client, we're gonna build this right after I explain this. It's a wrapper around the OpenID client, which allows us to connect, redirect a user, um, create challenges for them when we use PKCE authentication, which we're not gonna do, and stuff like that. But there's some stuff here that we have to fix this any because yeah, we don't want it to be any, we want this to be typed. Then here the result we cast it as unknown and then as the token result body because we know from the OpenID we'll get the token result body that we haven't declared but we will declare. And there we go. So both these functions, the exchange for exchange code for JWT, when are we going to use this? So the user is going to want to log in using his browser, so he's going to be redirected to the Keycloak server. He's going to see a UI, a login page, where he's going to put his email address and his password. If that is correct, Keycloak will give him a code, and then he will redirect the user to a callback on our front end. This callback is configured by us, and that the code that runs on this callback route is controlled by us. So on that route, we will make a request to our server and call this function exchange code for JWT. We're going to take this code and then we're going to generate a JWT by talking to Keycloak. And Keycloak will make sure that this code is actually valid. It is a real code, not one that the client made up, and provide us with JWTs. Then those JWTs we can provide them to the client, and now the client is logged in and he can use these JWTs to make requests to our server. That's how this works. And the refresh token is, well, each JWT is only valid for like 5 minutes. Uh, this is configured in Keycloak, but that's the default configuration, and we haven't changed that, and that's pretty good. So we're gonna keep it at 5 minutes, and in our application, our front end will be responsible for every 5 minutes, every like 4 minutes maybe, we're gonna make a call to the backend and refresh our tokens. So usually you don't put 5 minutes for token validity time, but we're gonna keep it at 5 minutes because we're gonna implement our refresh tokens. And so um, this here creates a JWT, which the user can use to authenticate on our servers, and also a refresh token, and they can use that refresh token, which is valid for longer than the JWT token, in order to refresh their JWT token. So I hope this is clear. If it's not, then don't hesitate to leave a comment and I'll explain further with whatever you need. So we're gonna implement an open ID. So open ID, no, client.service.ts. So before we continue, we have all these errors in safe assignment of an error typed value. So we're gonna go in the ESLint configuration. We're gonna disable this because I don't think these are errors. Our project is working fine and we don't have errors. This is probably ignorance on my part because the fact that ESLint is saying this is an error, it's probably right, but I'm still gonna deactivate it because I don't know what it's used for. If someone can enlighten me, then please do. So there we go, we deactivated it, so now there we go. These errors are gone. Does this make sense because it doesn't know the type yet, I think. Yeah, because this type isn't resolved. So let's go inside here in the OpenID client service and read about all of this. So we're gonna install this as well, npm add OpenID client. So what does this do? This OpenID client service, it just assigns the client, which comes from the OpenID client type, and it assigns it as a variable of this class. Now, since this is asynchronous, we need to create a factory, and so we inject the config service because inside the build OpenID client function, we want the config service in order to make sure that some environment variables are accessible. So we have all of these errors. Module OpenID has no exported member issuer. If I remember correctly, because I've implemented this on another project recently, this is because we're using a later version of OpenID 6.5.0 apparently, but these types only exist up until a certain version. So it would be a good idea to use the new version, the latest version, the 6.5.0, but I haven't looked into that, so we're gonna downgrade this to 5.7.1 because that's what it works with. So let's downgrade OpenID client here. So we're gonna up and we want 5.7.1. Okay, there you go, that solved those issues. And I see I still have ESLint issues with other like this one, this error, unsafe call of an error typed value. So I'm gonna deactivate this one as well. In fact, I'm gonna take the configuration I have in another project. There we go. Okay, there we go. Now we don't have these errors anymore. Okay, so build OpenID client. It creates our OpenID client asynchronously because there's an await here. We inject the config service here, and this one will be used inside our module. But for now, we're going to remove all of this and we're going to import it little by little. So the auth controller is here, then the OpenID, the auth service. Have we done it? Yes, we have done it. Let's look at it. Yes, I've explained this, I remember. No, it can't find this one. Why? There we go. Yeah, we're gonna have to create those, but not yet. Let's continue looking in the module here. So the auth card we haven't done yet. So this is an important part, and this is the most important part. So let's continue doing the auth token service. Okay, so for this one, we're gonna start by installing npm add JSON web token and jwks-rsa. We will create these types a bit later, and we're going to create a user service later as well. First, I'm going to explain all of this. So what does this do? JWKS stands for JSON Web Key Set, and what it does is it allows you to get the public key from a certain server, in this case Keycloak, and then with those keys we can verify the JWTs from the user that the user provides that have been generated by Keycloak, and we can verify if those are really generated by Keycloak and if they're valid or not. If they're not, then well, we'll know because we know the public key from Keycloak. So here we've declared a function token to payload, which takes the raw token into an argument. So this is just a bunch of letters and numbers, but we have removed already the bearer part like this, and then there's a token like this, a bunch of base64 encoded string. Now we decode this token using a JSON web token. Also, there's no types for this. We probably have to install it separately. So let me just install this npm add -d at types/JSON web token. There we go. Now we have the types for this. So we use the decode function and later on the verify function over here. So here the key ID. So the kid is the key ID. I'm not gonna go into details too much because I've seen that we're already at half an hour in the video. And this isn't a tutorial about login specifically, we want to just implement it. And then we define another function, validate token. This one makes sure that the token has the required scopes that we want, and also make sure that a user exists for this token. Since Keycloak manages the user IDs, we are just going to create a user in our system so that we can have linked GraphQL stuff to the user's ID. But it's Keycloak that generates the user's ID originally. We will just create an object representing the user using that same ID generated by Keycloak. So that's what the server does. This service does. Yeah, there we go. And it returns the user roles, and the isAdmin boolean. So now, we still have the controller to do, and we have to create all of these types and the user service. And we are already at 26 minutes. This is gonna be a long video. So let's implement the JQL auth card because that won't be very long. Okay, so there we go. Here's the code. So what this does is we on everywhere we are going to define this guard, which is on every single route, because here we define it as an app card. We will run this function. This class extends auth card from here in SJS passport and which type OIDC-JWT. We are going to make this. And it calls super, and it calls if it can activate, so which means does he have permission to go on this route? So is this a valid token? But we do not want to call this on public routes. For example, the routes that allow the user to log in or to get his JWTs using using his code. Well, we want it to be a public route, so we are going to create a decorator. We're going to say public.decorator.ts, and we are going to define it just like this. There we go. We are going to define this right now. Here constants.ts, and there we go. So we're going to define it like this. So this should be good now. Yeah, there we go. Oops. Here this should be good as well. Yes. So now we go back here to the service, no, to the module. I want to go back to the module. We're gonna import this, and now we're gonna create this part. So here I'm gonna create a strategy folder, strategy. Yeah, I spelled it correctly, I think. Strategy, yes. And we are going to call it jwt strategy.ts. There we go. So we're gonna add here passport-jwt, and we're gonna take a look at this. So this uses our auth token service and creates a strategy, a passport strategy. We name it OIDC-JWT. This name has to be the same as the one that we've declared here in the auth card. And this is all to make sure that it's gonna work with Keycloak. We say which issuer it is. So this is an environment variable, and we're gonna give the URL to Keycloak. Here there's a missing type. We are going to create this type. We're gonna say custom dash request dot type dot ts. Here we go. So we still have a lot to do. We have to create a user module, and we have to create all the types in the casino common. So the roles, what else is there? JWT payload, and the bodies for these responses here. Still have lots of stuff to do. Also here, this is not a factory anymore. I just refactored it right before showing to you, but we are just going to use it like this. We are not going to use a factory. A factory is when you declare it like this because it has to be asynchronous, but it's not asynchronous anymore. The old implementation of this was. Okay, so now this module is good. We still have to create the types. So let's go create some types now. So we're gonna go here into the packages, common. Let me start here by adding a roles.ts and export enum roles. We want there to be user equal user and admin equals admin. This should be the same names that you have inside init Keycloak. Inside, where is it? Here, user and admin. Because our mapper will make sure that these roles are put inside our JWT. Okay, so we just created the role. Where is my file? I don't know. We're gonna go back here and we are going to add another type here, the JWT payload. So this is what Keycloak's payload looks like, except for this. This is added through the mapper that I just talked about. Okay, and now we're also going to come here and say we want a REST folder, and inside the auth folder, and inside this auth we have a refresh file which creates this schema, and we have to add SOD to this. So we're gonna go do this right now. We go to the packages and common pnpm add SOD, and here in the token result we define another schema which is the response of Keycloak. Now we're gonna add one more type over here, the exchange for code body type, which we didn't have before. Here we had an any, so we're gonna be able to replace this. So we're just gonna come inside our common here and we're gonna build this, because otherwise it's not gonna recognize the types. And we're gonna make sure that now it's good. Let's see. No, it is not good, and I know why. Because here in the index file we have not exported it, so we have to export everything from the roles and export everything from the interface, export everything from the rest slash auth slash this, and we're just gonna, what am I doing? Up. We are gonna copy and paste this multiple times, just like this, and here we're gonna change the file up, and also I'm gonna remove this test, I think. Yes, I'm gonna remove this test right now. There we go. Up, and we're gonna build again. And then we're gonna go look over here. If now it finds the type, I also am gonna import this. Here, yes, it finds this type. So we are going to add here, what's it called again? The exchange for body, for code body. There we go. Now we still have to implement this. And there you go, this one isn't very long. We just define a route exchange code for JWT, which calls the service function exchange code for JWT. We type the body, and very important, we mark it as public, because remember in our module here, we defined the JQL auth card for all the routes. So we need to specify when we do not want to use this card. And we define it, we specify this by doing @public and importing it from our public decorator. Remember, we've defined this. And how does this work? Because here inside our JQL auth card, it checks if this tag is set, then we just return yes, you are allowed to pass. We don't care about if the JWT is correct or not, or if it is even passed. So that's how it works. So I just ran a pnpm type check to see what I missed. So in the JWT strategy here, we haven't imported this, but let's do this. Up, there we go. And inside custom request type, we don't have a user type, so this is what we're gonna do next now. We are going to create a user module. Also, before I forget, here we are just going to come import our auth module. There we go. And now we're going to create a user module. So before we look into these files, we're just gonna come and look for a schema file, up our Prisma schema file, and we're gonna add a user which has an ID, created that, updated that, and an email that is unique. That is it. Now we want to pnpm codegen. What does codegen do? Just for it to remind you, codegen, it generates the Prisma schema and then it runs GraphQL codegen. So this GraphQL codegen complains because he doesn't find any files that satisfies his requirements. It's because we've never implemented any queries, but that doesn't matter. We just need this to run, so that this should have run, but I'm just gonna run it again just to make sure. pnpx prisma generate. Okay. Also, we need to pnpm migration generate because we haven't generated the migration. So the database isn't up because we haven't started our Docker Compose. So Docker Compose up, and then, okay, should be good. And now if I run the migration, pnpm generate, we're gonna just call it the add user, even though for now the names of the migrations don't really matter. It only matters that later on in the project. Okay, there we go. So now we go inside our user module. So user module, nothing more basic. We have the Prisma module, the user service, and the user resolver. The user resolver just defines um, a me query that allows you to get information about you. This type is not found. Let's see why. Just before here, I do not want to use this, and we're just gonna say user not found. Perfect. So why is this not found? So we haven't added the generator to create our types. We could use the Prisma types, but we don't want to. We want to create using a nest the Prisma Nest.js GraphQL generator. So this is how you configure it. Alright, here you can look at this issue if you want to see where I got this from. I really like this emit single argument because it allows to only generate a single file, and this is important because otherwise it creates you thousands of files if you have a large schema, which is annoying. Right now we only have one model, so it wouldn't create 1,000 files, but I assure you it gets annoying when you have 1,000 files and your git changes are completely ruined because you have 1,000 files that are modified. So now if we run pnpx prisma generate again, let's see. So it's not happy about this because we probably haven't installed it. So pnpm add, we add this. So there we go. I added it and I ran again pnpx prisma generate. Now it generated me what I wanted. And this creates us a lot of stuff, a bunch of types. And now we should have the user type as well. Actually, I just noticed that here we provide an output for the Prisma files. They're being generated here. I do not want that, so I'm gonna delete this here and delete the line here, and we're gonna regenerate it because I don't want it to generate it there. I want it to generate in its usual place, which is in node modules, and that's probably why we didn't even have the user type, yeah, in here. That's why. So, but we are going to use this type. Actually, no, for this one we are going to use the Prisma type. But why did we even install this? Right now we don't need it if we go into the Prisma schema here. But we could do stuff like this. For example, we can divide a hide field, and this allows us to create a type without the email field, for example. And this comes in handy when you have complex schemas or when you want to add custom validation to your Prisma schemas. For example, I want a name for my user and the name has to have at least a length of 5 characters, for example. Well, this becomes easier to implement with this library. But right now we don't need it, so you could just skip this part, this installation if you want. I'm gonna remove this again and I'm gonna continue importing the user everywhere. So it doesn't matter which one we use actually because it's just the same right now. If I do pnpm type check, so we do have problems. So we've looked at the module, we've looked at the resolver, we haven't looked at the service. So here's the service. And why is he not happy? Let's see. He's not happy because this Prisma service over here, it looks for this file which doesn't exist because we just moved it earlier. So we want it from here, and now it knows that the user exists. If I see, we have autocomplete. If I remove it, there we go. So this one is just an easy little service. It creates a user, it checks if it exists, and it finds it by a user ID. Why is he not happy? User is an error type that acts as any and overrides all other types in this union type. I'm not sure why I have this error. I'm not sure how to fix this one. We're gonna see if it runs even with this, and if it doesn't, then I'm trying to fix it. So it doesn't know class transformer, so we are going to install this class transformer. So this allows us to transform objects before they are passed to the client, or vice versa. It allows us to make sure that what the client is sending us conforms to certain types. For example, if we go back to the auth controller, here we pass the type, and now because we use class transformer, actually not in this scenario, but let's say that we create a type test dot type dot ts, and I say it's an input type. For example, this type, if I use it now in a mutation or a query, then it will make sure that the name here is not empty. So this is the same kind of stuff that we can do using what I explained earlier, using this here. But this package will do it for using configuration inside here and using triple slash and something, and it will you don't have much control over what you want to use and which types it will apply it on. But this you do have a lot of control, but the downside of this is that you need to create your type yourself, which is annoying. But the other one, it allows you to create types automatically, and that's convenient. So I use both generally, but I try not to use this one too much because I like the auto generation of types. And so also I forgot to mention that I added pnpm add class validator because I started by explaining class transformer, but I ended up explaining class validator. So class transformer is a package that allows to transform your sort of JavaScript objects into classes and vice versa, and so also classes to JavaScript objects. So they are often used together because we want to convert a user input into a class and then make sure that all the members of the class are the conditions of those members are respected, such as these ones. So I'm going to delete this again because we don't need it. Now if we run again the type check, okay, we're good. So now pnpm dev, pnpm start dev. Okay, so we have our an error get or throw into in JWT strategy line 22 up. Okay, so there we go. So apparently config service is null during the creation of during the calling of super. So I have to use the basic process.env dot something, and now we have another error, but this is because all our environment variables aren't set, so now we have to configure those. So here we go. Here's the configuration with all the necessary variables. So we provide our issuer, which is our Keycloak. We provide the callback. Here you have to make sure that it's the same callback that you've provided in here inside the Keycloak init file. What else? So this is the URL, well, URI to the JWKS server, so Keycloak as well. All of it is related to Keycloak. And also I forgot to declare this variable here, so this is the secret, and the secret is equal to this here. So now this should be better. So let's see if this fixes it. Okay, a new error, so that's a good sign. We're moving forward. Nest.js can't resolve dependencies of auth token service. So it is auth token service here, so it's a user service. This is probably because the auth module needs to include the user module, but I think we're gonna use the user module in a lot of places. So I know this is not a problem because it is already global. I was about to make it global, but it isn't. It's already, so let me think of something else. Well, this is strange. Ah, no, actually, I think I just figured it out. So I added user module here and then it worked. Even though we declared this one here, the user module as global, but it actually wasn't registered at all because inside the app module we never imported. So if I use the user module here and then remove it from here, then it should still work because it's a global module. There we go. So the service is running. Was considering continuing doing the front end and implementing the callback, etc. But the video is too long right now, so I'm gonna stop here and we'll handle that in the next episode. So if you like the content, then please like and subscribe. If you have any questions, then comment and I will answer them. And have a good day.